Alright guys, today's lesson is Chapter 7, Lesson 2, Prime Factorization. Our objective is 6.7a, generate equivalent numerical expressions using order of operations, including whole numbers, exponents, and prime factorization. Okay, in the little bit of space that I left you, let's go ahead and write. Whole numbers are either prime or composite. You'll learn that in 5th grade, so a little bit of a review. 0 and 1 are special because they are neither prime or composite. Every number has 1, so 1 is neither prime or composite. So let's review from last year. We have 35. We're going to write the factors of 35. Well, we know every number times 1. 1 times itself equals 1 times a number equals itself. Okay. What else can we multiply to get to 35? Well, I know I have 5 and 7. Anything else? Nope, that's it. So 35 has a total of 4 factors. So since 35 has more than 2 factors, it is a what? Think about last year. Yep, it is a composite number. Okay, about 17. Okay, always 1 and 17. Can we multiply anything else to get to 17? No, we cannot. Okay, so since 17 has exactly 2 factors, it is a prime number. Okay, now every composite number can be written as a product of prime numbers, meaning we could multiply prime numbers together to get a composite number. Okay, when we do that, that is called its prime factorization. Okay, and we use a factor tree, which is a diagram that can be used to find the prime factorization of a number. Okay, so let's look at example 1. We have the number 300, or excuse me, we have the number 120. We're going to find the prime factorization. And I've given you a triangle. Why do you think I've given you a triangle? Well, what do we say that we use? We use a factor tree. So if you think about Christmas tree, triangle kind of looks like a Christmas tree. So this is going to be like our template. So to start, we need to write the number that we're finding the prime factorization of at the top. Okay, so 120. Anytime I see a number that ends in 0, I know that it's always going to have a factor of 10. We can multiply it by 10. Okay, 12 times 10 will give me 120. Okay, our second strategy is we need to label our numbers. Okay, I know 12 has more than 2 factors, so it is a composite number. 10 has more than 2 factors, so it is also a composite number. We want only prime numbers, so that means we're going to keep going. So I need to find the factors of 12. I know 2 times 6 will give me 12. And I know 5 times 2 will give me 10. Okay? Make sure that we're writing the multiplication sign, because if we were to work backwards, if we were to multiply these numbers, it would lead us back to the number that we started with, okay? 2 is a prime number. 6 is composite. 5 is a prime number. 2 is a prime. So now we need to break down 6. Okay. 2 times 3 will give me 6. Okay, and we need to keep pulling down the other factors that we still have in our tree. Okay, so I'm going to pull down 2 because that's still part of our tree. I need to pull down my 5 and pull down my 2. Okay, so we know 2 is prime. I know 3 is prime, and so is 5. Okay, I have all prime numbers now, which is what we want. So I've completed my factorization. My next step is I'm going to rewrite my prime factorization with all of the numbers that are the same next to each other, okay? Meaning I'm rewriting it to where I have all my 2's together. So 2 times 2. We have another 2. Then I have 1, 3. And I have 1, 5. Okay, and the reason we're doing that is because our last step is we're going to rewrite our equation using exponents. So starting with 2, how many times did we use 2 as a factor? We used it 1, 2, 3 times. So that's going to be 2 to the 3rd power times 3 times 5. And that's our prime factorization of 120. Okay, let's look at another example. Number 4. So we have 36. First step, write your number up at the top of your tree. I know 6 times 6 gives me 36. I know 6 is a composite number. So that means we need to keep going. 2 times 3 will give me 6. I know 2 only has 2 factors, so it is prime. 3 is also a prime. I have all prime numbers. So are we done? We are. I have all prime numbers, so our prime factorization is complete. But now we're going to rewrite our equation to where we have any numbers that repeat next to each other. So here I have a 2. I have another 2. And we have 3 and 3. Okay. We use 2 as a factor 2 times, so we can write that as 2 to the 2nd power times 3. We use 3 as a factor 2 times to the 2nd power. Okay, number 5. Now we have negative 70. Okay, and don't let the negative fool you. Okay, so we know a negative times a positive does give us a negative. Well, we also said earlier that every number has a factor of 1. So what could we write to make this easier on ourselves when we're talking about negative 70? Well, if every number has a factor of 1, I know negative 1 times 70 will give me negative 70. Okay, and we know that 1 is neither prime or composite, so all we have to do is leave that negative 1 alone. Just make sure that we carry it down. And now we're going to find the prime factorization of 70, because we know that 70 is composite. I have a 0 at the end, so I'm going to use 10 as one of my factors, times 7. You need to bring down your negative 1. I know 10 is composite, 7 is prime. So we need to break down 10. I know 2 times 5 will give me 10 times my 7 times my negative 1. I know 7 is prime, 2 is prime, and 5 is prime. So the prime factorization of negative 70 is going to be negative 1 times 7 times 2 times 5. All right. Okay, last one. Now we have negative 1,260. Bigger number, guys. Okay, but we know that if I have a negative, let's go ahead and make it easier on ourselves. We have a negative 1, and then we have 1,260. I have a 0 at the end, so I know that I'm going to have a factor of 10. I know 126 times 10 will give me 1,260, so 126 is going to be our other number. Okay, we know this is composite and composite. Don't forget to bring down your negative 1. I know 2 times 5 will give me 10. 126, let's see, 6, 7, 8, 9. If I add up all those digits, it gives me 9. So that tells me, based on our rules of divisibility, that it's divisible by 3. So we can work backwards to see what that gives us. Okay, so 3 times 42 will give me 126. Okay, I know this is prime. This is prime, prime, and composite. Bring down your -1. What times 42 will give us? What times what will give us 42 is what I meant to say. Let's see, I know 6 times 6 is 36. So 6 times 7 will give me 42. Okay, we need to break down 6. I have 2 times 3 times 7 times 3 times 2 times 5 times a -1. Okay, I'm going to rewrite it over here as -1. Sorry, I'm running out of space, guys. Positive 2 times 2 times 3 times 5 times 7. So I know I have -1 times 2 to the second power times 3 times 5 times 7. And that's it. All right, make sure you bring this with you to class tomorrow. Actually, hold on, guys. Sorry, I left off a 3. Uh-oh, times 3. 3 to the second power. We had 2 3s over here. Okay, now we're done. Bring this to class with you tomorrow. Have a great night.